ADMSLC.com. ADMSLC.com.
Okay. Discuss the percentage error. Okay. I can say percentage error acceptable. Acceptable percentage error. This means that we prove the formula of moment of inertia, that is I is equal m over the integral of r dv. We prove that, right? Because we use this formula to find the expected value, right? So we prove this formula. Acceptable percentage error mean we prove it. Now evaluation. From your results, answer these questions. Now, for this and this, I have the same I almost, right? As we see from the result. Select the answer. T depends on the mass of the shape. T depends on the I. Which one is right? T depends on the I or on the mass only? So I. See. This T here depends on what? On I. So this is the answer. Right? T depends on the moment of inertia. It's not depends on the mass. Because sometimes we have different masses, but we got the same T almost. So this depends on the moment of inertia. Now, for this and this is the same mass and same R. Solid cylinder and hollow cylinder. Okay? So, select the answer. I depends on the mass and radius only. I depends on the shape of the rotational symmetric body. So which one is right? Yes. Because this is when he said only, means it's not depends on the shape, right? But he said depends on shape of rotation, and he's not saying only. So this is logic. I mean, it depends on this and depends on the mass and the radius. So this is the most acceptable answer. Here I have the same mass and same material, same shape. Shape and mass is the same. So select the answer. If M and shape equal, like the solid disk and solid cylinder, shape, mass and shape equal, I is proportional to R square only, I is proportional to the R only. Which one is right? Square. Okay? So now, from the evaluation, moment of inertia, on three significant parameters, what's this significant? It's the shape, mass, and what? And R square is the radius, right? This is, radius of rotation, right? Squared. This is the three parameters effect on my, right? Okay. Now, the last one, he said, a hollow body has a greater moment of inertia. A hollow body, this one, has a greater moment of inertia than a solid body, than this, with the same mass and dimension. Why? Why we got 1.5? Why? Because of the distribution of the mass. Do you get my point? Because a solid cylinder, this is because, I can say because of the distribution of mass around axis of rotation, right? Hollow cylinder, all mass on R distance, right? but solid cylinder, I will write it here, sorry for that. Solid cylinder mass distributes from R equal 0 to R equal R capital, right? That's why I got the, so these are the answers, and I think this is very nice experiment, right?
ADMSLC.com